Awesome.
Wonderful. This is good.
Say hi to everyone online.
Hi everyone online. We're so glad you're here. We are just going to rally the troops and get folks to come forward, and we've got a great presentation today. And for those of you online, put in the chat where you are. We are going to tell people in the audience to scan this QR code for CE credits, and I will talk to Sai about what to do if you are online for CE credits. So we'll get started in just a minute. We're so excited that you're here.
It's not the kind of I was looking at you guys, and I wanted to say hey. This is Charlie.
Hi, Charlie. No, Tyler. Tyler, nice to meet you.
So Tyler and those are my students.
Can you take some photos?
I'm going to ask.
Would you like to take some photos? Yes. I love it.
Okay, that'd be amazing.
Okay.
You're supposed to sit in front.
That would be great. So we have BSA, well, I'll have you come up. Well, we have BSA's president, Alison Nash, to kick us off. We're so delighted to be here in the BSA space, and so we'll have Alison kick us off.
And I'm assuming that this is all like the Zoom and everything is working for everybody. Everybody can hear us. Okay. So I'm really delighted to be here tonight. I'm glad that people were able to brave the heat and enjoy the air conditioning of the BSA. But it just reminds me of the heat now, this time of year. It's like, this is why we're gathered here. We are living in the moment today. And when we think about resilience, we're the first thing that comes to my mind is the ability to bounce back. But it's also founded in knowing your neighbors, being socially connected, being together in this space and community. And we have understood for years how important mitigation is, reducing carbon emissions. But I think right now we're in a moment where there are tremendous opportunities for architects to lead and partner in adaptation work that's necessary for us to all live in community together. I wanted to share with you a little bit about the AIA National Strategic Plan, which is available on the AIA website. It was just launched, and it's for 2026 to 2030. So it kind of gets us to that 2030 mark. And the vision is, what do we want to become, and what kind of world do we want? Which is a great open-ended question. And I'm always thinking, well, what is my answer to that question? What is our answer as a BSA community to that question? And I'm not going to go over the entire plan with you, but I wanted to raise up some of the things that are in the AIA strategic plan that I think the BSA can latch onto. The BSA is currently in our own strategic planning process, and we've had a kickoff collaboration session with the board of the foundation and the board of the chapter, our executive director, and we're kind of have the juice of some ideas flowing, and we'll be launching a new strategic plan next year in 2027. But back to the AIA strategic plan, they have three core principles, and these are defined as what we stand for and what guides us. Architecture is for everyone. The future is regenerative, and collaboration amplifies impact. So I love that those are the three principles to guide us. And the regenerative one, a quote from that is, architects create buildings and places that restore ecosystems, strengthen communities, and advance a climate positive future. I don't know about you all, but I've been doing sustainability for a long time, and it's really invigorating to hear a national organization that represents us speaking in these terms. And if we go to their goals, they have a really clever acronym, PACE. AIA is setting the pace. So PACE stands for practice, advocacy, climate, and equity. And that'll help you kind of remember what the goals are. So I'm not going to go over practice and all of them, but the advocacy role I think is important. And the goal is to strengthen our voice as advocates. And the vision is that we are trusted civic leaders who can clearly articulate the value of architecture and shape the decisions that affect our communities. So I ask you all, are you serving on a board? Are you involved in your local town or city? Do you show up to public meetings? And think again, like how can you show up as visible, influential decision makers to shape policies, investments, and outcomes that affect all of our communities? I think resilience is really at the core of that as well. The climate goal is to elevate community resilience to address climate. And the AIA is really focused on this goal, on making sure that we all have tools, resources, and partnerships that can be leveraged by firms and practitioners to advance climate action and regenerative practice. So in order to do that, the strategy is to make sure we have the business case for adaptation and mitigation. And I would invite you to think, what are we all using? What are you using to communicate the business risk and value case for climate action to our clients? And another strategy is to foster collaborative practices for regenerative design. How can we accelerate decarbonization and regenerative outcomes by using shared frameworks and expectations? And what this brings to mind is the idea that, are we all building relationships outside of projects with our design partners? Are we, are there engineers in this room? Are there civil engineers in this room? Are there landscape architects? Like how could we at the BSA welcome more voices into the room so that we can make sure we have those relationships in place when the challenges come in the projects? So I just want to leave with you a little glimpse of some of the ideas we're thinking about here at the BSA in our strategic planning session. A couple of the sentences that we needed to complete, we had to start them with the BSA will. And so two that I thought were relevant to tonight's talk were the BSA will become an accountable convener who elevates architecture as a civic practice. And two, the BSA will elevate design culture by expanding public engagements and increasing design opportunities for all. So I want to leave you with those two thoughts, and I'll be here for the remainder, so I'm happy to talk with you all afterwards if you have any questions about what's going on in the BSA. There's so many good changes coming forward, a new brand, a new website, a new space that I look forward to seeing you out at in the future. Thank you.
Thank you so much. Thank you so much, Alison. Amy Loxford-Coco, Studio BSK, and I'm a co-chair of the BSA COTE. And we have a quote here from Maya Angelou, and she talked about surviving is important, thriving is elegant. Resilience is about survival through nature's most intense moments. It is how we bend and don't break. I asked our presenters what they would like to take away from today's session, and two of these were optimism and hope and knowledge. So today we have an incredible lineup of speakers. Speaking to policy, we're going to go from the kind of that big high-level view and circle to practice to education. We have Amber Galko, Senior Resilience Design Reviewer from the City of Boston Planning Department. We have a civil engineer here, so we are engaging with all levels of our practice cohorts, AEC industry. We have Derek Anderson, Professional Engineer Associate at Arup. From Ellenzweig, we have two architects, Peter Herman and Jacob Werner. They're going to present a wonderful case study at Maritime Academy, forgive me. And Tyler Hinckley from Perkins & Will, Director of Regenerative Design, will be presenting to us on his project at Columbia University. And Jacob and Tyler teach a course at the BAC that they've taught for many years, and three of their students, they're going to introduce their course, and three of their students who are now graduates of the BAC won the AIA Student COTE Award in 2024, and they are going to present their wonderful project. So we have some learning objectives just in terms of management to get this is 2 learning units HSW, so scan this if you're in the room, and Cy has posted if you're online. And without further ado, Amber Galko, City of Boston Planning Department.
Hi everyone, thanks. Here. Does this sound okay?
Yes.
All right. Thanks so much for being here today and letting me talk to you about the work that the City of Boston is doing for resilience. So I'm going to talk about the planning and implementation of our Coastal Flood Resilience Overlay District. And starting at the citywide scale of our resilience plans and policies, all of this work came out of the 2016 Climate Ready Boston report. This was a comprehensive vulnerability and risk assessment looking at the hazards that our city is most likely to face in the future, being heat, stormwater flooding, and coastal flooding. And my focus today and in general is on the coastal flooding piece. So as we know, we are a coastal city. Over the last 10 years, we've seen more and more nor'easter storms that have hit and caused flooding, also sunny day flooding in king tides. And we know that climate change is only going to exacerbate these areas. So in the last decade, there have been many, many different resilience planning and policy pieces that the city has worked towards making, and the sea fraud is just one of those pieces. But over a 5-year span, the city wrote a comprehensive neighborhood resilience plan for every neighborhood in the 47 miles of coastline. So we have the ideas for our district scale solutions and which flood pathways need to be addressed. And what I'm focusing in on are the adapted building strategies. Because of those neighborhood plans, hopefully these buildings aren't going to see water. But for right now, until we have the billions to build these strategies and the full district scale solution across our 47 miles of coastline, adapted buildings need to be addressed. And in each of those neighborhoods, we are looking at many, many different ways of providing resilience. We have lots of different options, and it's not always the best fit one scenario for everything. So, looking at raised harbor walks, nature-based solutions, flood walls where we have to, but also doing that belt and suspenders approach of adapting the buildings and structures. And the 2 pieces to address those building and structures that came out of Climate Ready Boston are zoning to protect our life safety and property, and to create specific resilient definitions within our zoning code, and also a guidelines document to go hand in hand to advise on how buildings in the context of Boston can be made resilient. And I'm going to go through each of those pieces. Excuse me, there we go. And resilience review that came out of the zoning is looking at these 4 pieces hand in hand. We're looking at both the resilience standards in the architecture, sustainability co-benefits, and how to integrate that seamlessly into the public realm. We are changing the shape of the city. Our streetscapes are changing. So how do we talk about design in a meaningful and thoughtful way with all of these pieces? And how can they relate to district scale solutions? Not just looking at a parcel by parcel basis, but where we can tying all of those individual pieces together. So first I'm going to go into the Coastal Flood Resilience Design Guidelines. So this is a design guideline document that looks at the specific building typologies here in the city at all scales. So from residential to our large commercial buildings. The guidelines document looked at case studies for both new construction and retrofits at each of those scales. And there are many different levels of design that the guidelines talks about. Building forms, building envelope, building systems, and it goes into each strategy that falls under those, looking at the cost considerations, resources, and technical considerations for each one. And there are also case studies of those building typologies that we mentioned. So how to retrofit at each scale to provide resilience and also best guidance for building new. And there are many different things that you have to start thinking about in your architecture that are outlined in this, like how your circulation changes. When you have design flood elevations that are suddenly 5 feet above your sidewalk, how can you thoughtfully design your circulation? Where should you put it? And this gets you thinking about different ways to do that at each scale. And then once your building is raised, what do you put under it? Do you do tuck-in parking? Do you elevate and wet flood-proof below, or elevate on fill? So the guidelines document is great in talking through kind of each of those pieces to start thinking about. And those outline the resilient practices that we review in our zoning. So our zoning is called Article 25A, the Coastal Flood Resilience Overlay District. It's not the most beautiful acronym, but we call it the CFROD. So it's what we got though. The CFROD boundary is a 1% chance storm in 2070 with 40 inches of sea level rise. And that level was kind of a mid-case scenario emission standard as decided by the Boston Research Advisory Group. And it's based off of the Boston Harbor flood risk model. So what we're trying to do here is we're trying to protect against risk to life safety and property damage and promote resilient planning and design. Every parcel within the city has its own base flood elevation. These are outlined in Boston's zoning maps. You can click parcel by parcel and get the elevation in Boston City base of your base flood elevation and the level that has to be protected up to. And these heights range anywhere from 13 along the Charles up to 20.5 downtown in East Boston. And what makes this different than other areas? So the pink that you see here are the maps that most other municipalities in the country use. The National Flood Insurance Program's flood insurance rate maps that show the FEMA special flood hazard areas. And these are modeled based off of historic storms. But once you start to add in the projected sea level rise, as well as future storm scenarios, you can see exactly how much further into the city this blue that represents the CFROD goes in. So there are many areas that aren't protected by required building code that we require resilience for through our zoning code here. What projects have to comply with this? Generally projects 20,000 square feet and up. So that falls within the city's Article 80 bucket. And smaller projects can also elect to comply. But the biggest thing that the zoning outlines is what that design flood elevation is going to be for each parcel. So the design flood elevations are base flood elevation plus freeboard, which is an element of safety. We don't have a crystal ball. The maps are the best we have, the best science we have, but we still don't know what's going to happen. So we require that element of safety. And that changes based on your project use. So 2 feet is required if you're a residential use or in a FEMA V zone or a high risk structure, but everything else still requires 1 foot above that mapped base flood elevation. And this also changes the zoning height of buildings in this overlay. So your zoning height is now measured from 2 feet above that base flood elevation. And as for residential uses, the design flood elevation for most uses is your protection height. That's the level that you have to provide resilience up to, but residential uses do have to be raised for life safety. So in your residential buildings, you can have parking, access, and storage below, but all residential uses or ancillary residential uses are raised in this area. So implementation, what does this look like in practice? Maybe, there we go. The zoning was adopted in 2021, so almost 5 years. We have had projects come through, and so far over 400 projects have been reviewed. We have permitted almost 3.5 million square feet, and construction has been completed on about 250,000 square feet of projects. These metrics are tracked in the new Climate Action Plan implementation dashboard, which tracks a bunch of resilience and sustainable efforts that are going on in the city. So it's fun to see that number go up. And I have a couple of case studies of what does this look like in practice in a variety of buildings. This first one was interesting. It was a repurposed warehouse that they wanted to put commercial uses into. They did a structural assessment, determined that the building couldn't be flood-proofed with dry means because the structure couldn't withstand it. So they thoughtfully designed a wet flood-proofing strategy, including breakaway storefront, including flood vents, and if the water comes in, hits the drywall. They also have a nice drywall detail 3 feet up at that design flood elevation. So if it gets wet, you rip out that bottom part and can replace it easy and get things back on track sooner. We have many waterfront master plans going on in the city right now, and we've seen some very thoughtful ways to have a continuous line of protection up at that DFE all the way across the site. 425 Medford has that continuous line of protection, and they're also committed to raising all buildings above the design flood elevation for that belt and suspenders approach. Once we get into some mixed-use buildings, we are seeing our public realm and our streetscape change. Normally, these are retail spaces that would be at grade, but they're being raised for resilience. So how do you have zero lot line projects that are raising? How do you still have a nice streetscape, buffer those edges? And what's the best design outcome? Design is subjective, so sometimes it's, oh, well, I don't want to see that 4-foot wall, or, oh, this is, for resilience, so we should be promoting things like that. And it's a dialogue. It's a dialogue with the city and with architects, and it's great to see kind of the range of projects that come out. This one this one needed deployable flood barriers, but they kept them at very minimum areas, just the entries, which was great to see. Downtown, we have a lot of office to resi conversions right now. That program is going super well, and it's really great to see buildings that have been standing as empty offices be reused into resi. But due to the existing nature of them, many of those existing finished floor elevations are below the design flood elevation, so they can't be used for residential. So we've seen some really creative mixtures of floodproofing strategies. How do you keep the retail dry but still allow residential egress to come out? So this one has wet and dry floodproofing to protect those spaces. And residential uses. This is one particular project where the design flood elevation was 6 feet above the existing sidewalk. So how do you start to mitigate that? And what does that look like? Can you always raise your residential 6 feet? This project was one that had a mixed use of the ground floor that were community spaces. So the corners of the building, they anchored with the community spaces at the sidewalk, but they used their exterior areas to work to create sloped walks that raised some of the plazas. So they kind of met halfway. They did have some dry floodproofing for those community spaces, some wet floodproofing for the lobby. They're still trying to meet in the middle, as opposed to having that 6-foot wall at the grade. And some areas of the city, the DFE can be higher than 6 feet. So we are seeing residential that create sacrificial ground floors. All of the residential uses are raised. They're measuring that height from almost a floor up, and the ground floor becomes sacrificial parking, access, and storage in order to keep those residents high and dry. Thank you for being here and for letting me talk to you about these projects.
Our next speaker is the talented Derek Anderson of AIA, civil engineer, and the floor is yours.
Thank you very much. Hopefully you can hear me all right. Really appreciate your time here tonight to talk about resilience. So, just jumped a little bit there. That's okay. So I'm going to talk a little bit about, well, first of all, a little bit about me. So I'm Derek Anderson. I lead our civil water team in our Boston office just over at 60 State. Civil engineer by background, doing a lot of work with flood modeling, stormwater design, and over the last decade plus, a whole heck of a lot of resiliency work. Two projects that we've worked on recently that I'm going to talk about some of the lessons learned from, building off of some of the work that Amber just presented from City of Boston, was our work leading community-led flood resiliency projects for both the North End and the Wharf District. This is nice. Yeah, we're kind of zoomed in here. I'm just wondering if we can zoom out a little bit there, but generally, if that's not working, we can, yeah, there we go. Perfect.
Is it? Seems like
Well, yeah, it's kind of zoomed in a little.
Yeah.
That's interesting. Technical difficulties.
Sorry, I just zoom fit screen.
Yeah.
So enter PDF full screen. It's sorry, I don't know why.
I think that's going to be fine.
Is that okay?
Yeah,
I apologize that it's
that's fine.
flipping the top.
Nah, we're good. We're good. We have to be resilient in all things. So this is the Wharf District. It extends from the Fort Point Channel over at the right side of the screen all the way over to Christopher Columbus Park at the left side, all along the waterfront of downtown Boston. That's what it looks like today. And what we are trying to help the community protect against is this. This is a 100-year flood, not in 2070, like we often like to talk about, but in 2030. So what we're talking about here is, if you remember Winter Storm Grayson from 2018 that flooded out MBTA's Aquarium Station, flooded up State Street, that's that storm happening in 2030. Similar for the North End. So here we're now just moving just north. On the previous map, we've got Christopher Columbus Park over there on the right side of the screen, all the way up to Battery and Burrows over by the U.S. Coast Guard. Similar flood hazards here with that same 2030 100-year storm. So we've been working with both these communities, working with the Wharf District Council in the Wharf District, working with the North End Waterfront Climate Alliance in the North End. Both are nonprofit organizations who are working to help improve the quality of life in their community. So these are volunteers who are just trying to do their best for their community and have been for quite some time. So they came together and said, look, we want to have a community-led resiliency plan to help give our residents, our business owners, the people who work, live, and play here a voice in what climate resilience means to them as a community. So I'm not going to go into a whole lot of detail on what the plans are, because I really want to get into how we've used some of the tools that Amber talked about, how those were really important for us as designers to be aware of and to integrate. I want to talk about the stakeholder engagement framework that we use to build unanimous consensus with property owners on these projects, and some of the lessons learned. So I really want to focus a bit more on the process of applying the work we've done than the actual engineering behind it. But I'll talk for just a moment about what the plans are to give a little context. This one is the North End. So we have Battery and Burrows Wharfs up there at the top, stretching all the way down to Commercial Wharf and Christopher Columbus Park at the bottom. Really just want to talk about the three lines on the plan here, just to give a little flavor. We've got that first blue line. That really represents a raised wall. So what we're doing with that blue line, everywhere you see a blue line along the waterfront, we're taking the harbor walk that's down low and raising that seawall up and raising the harbor walk up. So we still have that connection to the water, but we're providing a flood protection system with that seawall. In green, we are elevating the landforms to provide that same function, but that's a little stepped into the land a little bit rather than right at the water's edge and raising up the landforms in those areas. And then in that magenta color out in the water, we're proposing a number of floating breakwater docks, basically heavy-duty docks that help break down the wave heights so we don't have to go quite as high on the land. The other things I'm not going to get too much into, but we're providing a number of other co-benefits in terms of new waterfront parks and ecological improvements like wetlands and living shorelines. So similarly in the Wharf District, same color scheme here. The blue lines again are areas where we are raising up the seawalls and the harbor walks. The green lines are where we're raising up the land itself to act as a flood protection system. We've got those floating breakwaters here again. So just in terms of one spot, what this typically looks like at the ground level. This is in front of Harbor Garage downtown. You can see the aquarium, their theater there in the background. So today, we come along to the water and we step down on the harbor walk to get close to the water. And what we're proposing to do with our plans is flip that, so we will step up in the future to come up over this elevated landform that has a flood wall buried in it. What we're trying to avoid is a 6-foot tall wall that cuts off access to the waterfront, destroys what we know and love about the waterfront, providing an accessible walkway up and over the top and back down again, new seating and steps down to the water, and using this as an opportunity to incorporate the living shoreline you see there, as well as additional vegetation to really make this a world-class waterfront and not just a flood wall. So that's generally what we're looking to do throughout these areas. So with that, touching on the tools that we use to get there, because at the end of the day, we were successful in building support with 100% of the waterfront property owners, public and private, in both neighborhoods, as well as building support with the city and the Army Corps. So how we got there was the great work that the city has already done to lay the groundwork here and facilitate communities to come and take this next step. So I'm not going to go into great detail because Amber did a great job, but some of the things that we found really useful in Climate Ready Boston, there was great documentation of the public engagement that the city had worked on for years to identify the priorities, preferences, and the criteria the community had voiced and said, these are the things that we want people to consider when we choose between options for resiliency. So having that documented was fantastic so that we could build on that rather than have more meetings and burn people out with meetings and meetings and meetings. There was also clear identification of design flood elevations. Both we have the zoning viewer that Amber talked about at the bottom there, which is really about building level adaptation, and also the design flood elevations in Climate Ready Boston at the top. Those are two different elevations, just so you don't get confused. Climate Ready Boston is more about the neighborhood scale, which is what we were really using for North End and Wharf District, but we're also working with buildings that need a second line of protection, and that's the zoning viewer. But having those elevations saved, I can't tell you how much time and effort as we're working with communities to establish what needs to happen to protect them. Identifying the locations where flood protection systems could be placed was immensely valuable as a first pass with Climate Ready Boston. Preparing a series of toolkits. This one I think was from downtown and North End with different strategies for flood protection that could be applied to those alignment locations. Already having those vetted by the city as what was appropriate for these locations was really helpful. This one actually came from the East Boston Phase 2 Climate Ready Boston report. They really dug into social equity, and this was, I can't tell you how important this was for us because so many people in the Wharf District and North End said, we need to make sure that this waterfront is equitable. But what the heck does that mean when we're designing a flood protection system? And the East Boston report went into a good amount of thought in this and really boiled it down to the implementation side of that for coastal flood resiliency in many ways. Of course, there's a lot of conversation and engagement that comes into this, but in the infrastructure really plays into equitable access to the waterfront, making sure that we've got safe transportation to, through, and around our neighborhoods, and providing ecosystem health within our plans. So that was really helpful to build consensus around what we were trying to achieve in our work. And then finally, of course, the various flood resiliency guidelines the city has put out to make sure that we're providing the same level of protection in the same ways throughout the city. So fantastic tools. Could not have done the work that we did without the city of Boston laying the groundwork for this. Now, I'm going to change gears a little bit here and talk about the framework that we use to set up these projects and deliver them. This stakeholder group, this public-private partnership, was put together by the Wharf District Council. So the Wharf District Council had been around for a while as a group of residents and business owners. They wanted to really start building a coalition of support from day one, because they always knew that they don't have the money or the people or the will, quite honestly, to take the design to 100% and build it, nor do they have the authority to do so. So this was one step in the process. So really crucial was building a coalition of support to take it on to the next step. So they formed in partnership with public agencies, city departments, state representatives, they brought some private sector consultants in as advisors, and other nonprofit organizations that do represent the interests of various communities and groups within the city, as well as the property owners and marina dock operators. So brought all these folks in as part of the project. Now this is the stakeholder group. That stakeholder group on this next image is down at the bottom. This is the engagement model. This is how we made our decisions as a team. Now remember, this is not a project led by a public agency who would normally, we're talking about state representatives, we're talking about city departments who normally would make the final decisions. In this case, it's the community. So that's flipped. The stakeholder group is down the bottom. Still very important because what their role was to identify the goals of our project and to provide fence posts around what types of strategies would be viable and feasible and supported by those important stakeholders at the end of the day. So we're using that group and their intelligence to say, what can we bring to the property owners that's going to have buy-in, and is it going to be realistic? Our technical team also does the same, but more in terms of making sure that we've got the engineering solutions that are feasible, are constructible, are permittable, and are fundable. So making sure our benefit cost ratio is realistic, and we're not just providing pie-in-the-sky options to folks. But then we're taking that work and feeding it up to the top to our property owners. Now in this case, the reason they're at the top, something like 90% of the waterfront in these neighborhoods is private property. So this is not something the city can do on their own. They need this partnership, and they need those property owners to come in. When we talk with the Army Corps, they say their #1 concern with a flood protection project is property owners saying no. So if they get a whiff that the property owners are going to be like, we don't want work on our land, they're going to say, fine, we're going to build a 6-foot wall back at the road. So those property owner support massively important. So we put them in the driver's seat on making the final decisions, bringing plans and options to them that were already vetted to make sure that they could be supported by all the other stakeholders and could be viable, and saying these are the options, these are the plans that we can choose from. Let's talk about now what you want, what you need for you to support this. And putting them in the driver's seat was very empowering.
I'm going to ask a quick question. Where does the floating breakwater fit into this model, since that's offshore?
So generally that would still be on private property since those property owners own some of the water sheet. We're only proposing things in private property in these projects.
Thank you.
The Wharf District Council in the North End also were kind of in the middle there is the task management team just to manage the day-to-day delivery of the project and make sure we're meeting all of these goals. From there, this is a list of the property owners just in the Wharf District. We had a number of workshops with them to establish their priorities and goals, and at the very outset of things, establish a framework for how we were going to make decisions when we had to choose between options with different trade-offs. We had design workshops where we brought plans to them and said, what do you like, what don't you like, how do we make this good for you? And where two different property owners had some friction, we would have consensus building workshops to find common ground. This process and that framework we established on the previous slide resulted in unanimous consensus in the Wharf District, all 16 public and private property owners with the exact same outcome in the North End. And at the end of the day, we ended up meeting with the Army Corps and saying, look, we have a plan that's now supported by these communities. This is what they say they need. And the Army Corps said, that's amazing, because as I mentioned, that's their #1 concern. We ended up getting those plans incorporated into the Army Corps' Coastal Storm Risk Management Study, which is their plan to protect Boston Harbor as the locally preferred option. It's that lighter blue line on the shoreline. And in addition to that, there ended up being so much support for our plan and pushback from these community members for the Army Corps' plan, which again was a 6-foot wall back at the roadway that cut off the community from the waterfront, that the Army Corps has now dropped that inland blue line from their plan and is only advancing the plans that we have identified, or something very similar to them. So last bit here from me, lessons learned in the process. Really important when you're working with property owners like this to identify the decision makers. If you're working with a condo board, who has the authority to speak on behalf of that property? Also making sure that we are providing an option for confidential information sharing so that the designers are able to see the plans that property owners have for their properties without them being concerned that their neighbor's going to find out about it prematurely or the city's going to find out. So we actually had many meetings with property owners, and we didn't invite the Wharf District of the North End. It was just Arab and the property owners to talk about what their preferences and plans were. Building trust as an advocate. This took a little time to change people's opinions about what we were trying to do because they're so used to public projects. We had to really get them to really trust us when I said, look, we're here to be your advocate as property owners. If I'm going to come to you with my recommendations to protect the neighborhood, but if you say no, if you say I want something else and this is what I need, I'm still going to back you. I'm still going to represent you on that. I'm going to tell you you're wrong and why, but as long as you're making an informed choice, that is your choice to make on your property, and we will work around that, and I will advocate for you on your behalf. That went a long way to building that trust. Again, I talked about only presenting feasible design options right from the beginning, so we're not setting unrealistic expectations. Welcoming collaborative design throughout this process, making sure there's time for iterative design processes to really genuinely bring in the ideas from these property owners. And last is giving the gift of time. This is something I'll tell a quick story as I wrap up here that I went through over and over on this process. When we were meeting with one of the property owners down at Rose Wharf, we came to them and presented 3 options. We said, all right, you can not be protected. You don't have to protect yourself. We can protect the community without you. We can protect it back at the roadway. If you want to do that, that's what us. But if you want to be protected, here's a couple options for what that looks like. They looked at these options and they said, Derek, we hate this. This is horrible. These are awful. You don't know what you're doing. And I thought they were going to kick us out. So I said, well, sit with it, think about it, let us know what you would change or what you would want to do to protect yourselves. You've been thinking about resilience for a while because you are very exposed. What do you want to do? So they took 2-3 weeks. 3 weeks later, they came back and said, you know what? We really tried to think of a better way to do it, and we just couldn't. We understand, we now kind of get why those plans are happening. But remember, these are their homes. They moved there for the water, they've been living there for a long time, and they have an experience and a relationship with the water that we are fundamentally going to take away with this plan. They were very sad. They were understanding of why now, but they were very sad. But with a bit more time, they started to change, and they started to get excited about the opportunities that come with that change. Started to think about, all right, if we're gonna make this change, maybe we can talk about a better outdoor experience. Maybe we can bring people in a better way, have some gardens, have different access to the water. And they actually started getting really excited about it. And that only happened because we really gave them time to process this entire experience. And I saw that with many property owners there. So key lessons there. And with that, I will wrap up and pass it along to our next group. Thank you.
Great. Thank you so much, Derek. That was so wonderful, Derek. Thank you so much. Next up from Ellenzweig, we have 2 principals from the firm. We have Peter Herman and Jacob Werner. Jacob also serves on the steering committee for the BSA Committee on the Environment and on the AIA 2030 Working Group, and many other things. Welcome.
Thank you. So going forward. Perfect. Yeah. So we're going to present a project that we've done down on Buzzards Bay at the Mass Maritime Academy. These are people who are educating merchant marines and people who will be moving ships across the water. The project itself, there it is on the site. This is the site itself, and where you see the wind turbine, that is actually very close to where the building itself is going. And this is what the building will look like. It's scheduled to be finished near the end of the summer, so it's almost completed, and it's starting to look like this right now, which is very exciting. I don't know that it screams sustainability and resilience, but it's kind of a stealthy building because it is doing all of those things, and it is also it's designed so that it has a family resemblance to its neighbors. And so it's a kind cousin, I would say, to the other buildings on the campus.
You might get a little bit of a hint that there might be something happening with the building being a little above
Yes.
where the rest of the campus is.
Indeed. And also you can tell that these are all cadets in their uniforms as well. So just so you have a general sense of the overall program that they teach here. So it's workforce training for maritime people. This is a STEM education building, and so it has a lot of the classic laboratory spaces for organic chemistry, biology, and physics. But it also has specialty labs where they do things like crush materials, and they also have operational control rooms where students learn how to use some of the machinery to run their ships and the like. There's a
Fun stuff.
yeah. There's a makerspace design lab where they also are making things with 3D printers and other mechanical equipment and the like. They do lots of welding and other work like that. And then there are faculty offices and student gathering spaces. There's, and actually, 3/4 of the way through the design, they started looking at the rooftop. This was a 3-story building, and there was a penthouse on the 4th floor, and they said, dang, there's some really nice views up there. We could totally do some great fundraising. So 3/4 of the way through, we added a conferencing center on the 4th floor. And originally it was about a 36,000 square foot building, and it became 39.
Once you add the roof.
Yeah. So this is just some views of what the inside of the building is going to look like. This is standing in the lobby, and it's a modest double height space, but it's kind of got a signature sensibility to it for this space. That's looking at the mezzanine just above the lobby and down toward it. There are no monumental open stairways for budgeting reasons, so actually they're all enclosed. This one actually is sort of doubling as the monumental stair, and it's behind a 2-hour glass wall. There's the makerspace on the ground floor, and this is one of the typical lab spaces. In this case, it's marine science. There are 17 hoods in the project, and part of the resiliency strategy is actually that 12 of them are filtering fume hoods. And just so you know that all the labs aren't going to be pristine, this is a pretty good example of what.
Yeah, these things are really cool. They teach them how to work on boat engines and equipment, and they have these setups where you can actually tinker with how a boat engine works and things. It's pretty cool stuff.
So resiliency and sustainability really guided the design from the very beginning. So DCAM and the school were very much committed to making this a showcase building for a low EUI and resiliency. And obviously, because they're living on a floodplain, you can appreciate that aspect of it. So for us, we were always looking at it through the lens of the site itself, how the building was going to relate to the entire campus and its viability, understanding the relationship of the building to the overall grid, the local grid, and being able to survive for some time without it. And then obviously consideration for the climate as good stewards of the climate through the design and construction process. So part of the approach to resiliency is pretty fundamental. It was, first of all, you want to design robust because you want it to last. There's no sense in spending lots of money and embodied carbon and energy on stuff that you have to replace. So we really think of it as a 75 to 100-year building. And the other thing too was to appreciate the freeboard above the floodplain level that was predicted for 100-year storm in 2070. So we are designing and raising this building slightly beyond the flood level. The other thing too is to be sure that we could run this building for at least 48 hours after a blackout. We really wanted to make sure that we would lower the overall energy requirements for the building on a daily basis so that you wouldn't have to have lots of generators running or the like to get you through those 48 hours. So one of the things we really also did was we emphasized passive systems and approaches to particularly the building envelope. And because this building has a lot of fume hoods in, or relatively large number of fume hoods.
Compared to its size, it's a lot.
Its size.
Yeah.
We really also wanted to try and control the amount of once-through air that's happening, and so we used air acuity systems to help monitor airflow and reduce the airflow when the hoods aren't in use. So this is sort of an overview of some of the sustainability and resiliency pieces that went into this building as an overview. So first of all, we've got a pretty amazing EUI of only 52 kilowatt hours. I mean, of KBTs per square foot per year. And in so doing, we're actually at 45% of the ASHRAE 90.1 2010 standard. So this building started getting designed it's almost 4 years ago. So we were working with older stuff. But we also had to adhere to the Massachusetts Executive Order 594, and we managed to be 43% better than that. So what are some of the things that we did? Well, one of them that we had a huge advantage is the school itself is installing a ground-sourced thermal heat pump system. So we have this campus loop that we are tied into, and actually the primary mechanical equipment that distributes the geotransfer heat is located in this building. So the other thing we did too is that we actually raised the whole building 6 feet above the lowest level of the site. The site was at 12 feet, between 12 and 13 feet, and we're raising it over 6 feet. So that's a pretty significant amount of earth moving that we did. We also obviously are trying to reduce energy usage, and so we have an enthalpy wheel for energy recovery. As I already mentioned, we've got an air acuity system in it to handle the indoor air circulation.
Changes the amount of air delivered based on what it senses within the building.
Maybe use the mic, because a whole bunch of people
wow.
came in from the storm.
Sorry.
And
So,
no, it's just escaping the storm.
So the difference is when the hoods are not being used, the air is moving at 2 air changes per hour, and then when they are being used, it pumps up to 4. And then we also have the domestic hot water that's connected to the geo loop, so we're preheating all the water before it actually has to get heated up to the temperature for hot water. We were able to get very low U value for our windows, and there's an interesting story on that too that's coming up. And we were able to do similar for our walls, so you'll see a very nice wall section coming up that shows how well insulated we managed to do that.
So this is all really important fundamental homework that doesn't show up in a fancy design on the exterior of the building.
Yeah, exactly.
But is extremely useful to the upcoming information.
Yeah, that's the stealthy part of the building.
Yeah.
And then, we also were reducing energy costs by doing daylight dimming throughout the building. And also we have a much lower LPD, of only 0.6 watts per square foot instead of the typical 0.99. So what are the design drivers? So first it's the executive order from the state, then it's high winds, and it's sea level rise and potential flood conditions, and then being good climate stewards. So the executive order is basically, almost all of you are familiar with it, but basically it's a great way to get fossil fuels out of your life. We do actually have a backup boiler in the building for emergency, but and we are managing to meet LEED Silver.
So before you go on, it's the state making sure that state projects lead the way in sustainability. So since this is a state school, this is a key project to do that.
Yeah. And at the time, the International Energy Conservation Code for 2021 was our requirement, but DCAM was really insistent that we should opt for the Mass Stretch Code for 2023. So that is what we designed too, and so it's very high performance building design, and you can see in sort of the highlighted text there the various things that we're doing here. It's not passive house in terms of envelope air tightness, but it's pretty close.
It's a lab.
And it's all about DOAS systems, enthalpy wheels, and then we were able to get our site energy down too considerably. So some of the resiliency goals that the school needed to think about at the very beginning was Are we going to do good, better, or best for things like surge precipitation? How are we going to deal with wind and seismic? And through a whole sort of balancing act of cost and practicality, they opted for the good approach. So what this really has a lot to do with is making sure that we had all of our mechanical and electrical equipment raised up above the floodplain. So we have an electrical room that's at 18 feet and that everything else is up in the penthouse. We have good code compliant glazing and obviously we're meeting the seismic code.
It's interesting that what we did was just good.
Yeah. On those respects, yeah.
On those respects, yeah.
So wind hazard, let's talk about that. So really for us, the windows and the roof assembly, but particularly the windows, were the hot spot. And one of the things about the area right here, and you can see in the yellow circle, the peninsula in Buzzards Bay that the building is located on, was that we actually had a wind speed of 139 miles per hour so there's a risk category 2 here for hurricanes. And it also would have airborne debris, so there's the issue of missile protection. The wind direction is pretty straightforward. It's generally coming from the west, just like the Earth spins. So here's the deal. So the building requirements, we have to meet these categories. And the thing that is really depressing is that when you're at 139 miles per hour, you can't use triple glazing.
There are not available systems.
Yet. And so this was a big disappointment for DCAM and also for us, because what that meant was that we were going to have to use double glazing. And DCAM basically lobbied the AHJ, and we were able to get him to say, all right, the risk factor is actually going to be 129 miles per hour for this area. And so that means you can use triple glazing. Compliance granted. So energy trumped a little bit of safety factor. And
it was right on the edge. It's important to note that.
Yeah. So for us, what was exciting is, we're going for a U value of 0.42 to 0.23, and that's an exciting change. That's great, but what would be really nice is for all of us to try and advocate the window companies to work on a triple glazed window system, that would work and have a laminated glass at the 5/6 glass. So there are stuff's happening though, because there is now thin glass triple glazing that's starting to happen. They can fit into a 1 1/4 inch wide mullion pocket. So we think that this might end up being something that will become reality, and all of us can work hard to convince various glass manufacturers to move in this direction.
So this isn't just academic. We're doing another project at the University of Rhode Island right now that is suffering from this exact same thing.
And there we actually ended up having to go from the triple glaze down to double glazed.
It's a little bit higher wind speed.
It has higher wind speed. So the other thing we were doing too is making sure we've got a roof assembly that's not going to blow off. And what's important here actually is the lower detail that you're seeing there is just making the point that the first layer of insulation, which is not tapered, needs to be glued and mechanically fastened, and that it's only the tapered portion that gets adhered with mastic. And then the other part that was important is there's a walkout deck now. And for a while, they thought they were going to use concrete pavers, but you probably know that like these bison systems have a plate that goes on top of the corners of the paving to hold them down for hurricane winds. And they found that extremely unsightly and horrible. So what we ended up going with instead is Ipe decking, and those have, a kerf cut below the decking that prevents the hurricane uplift. So we went from what's on the left to what's on the right. Okay, so let's talk about sea level rise. Obviously you guys are aware of the fact that we're in a big flood zone, and so is our site. And the closer you get to it, you can see that the projected sea level rise is actually, you can see it here, but what sucks is when you get a 100-year storm and for the flood level for today. And then what happens in 2070? Well, it's a lot worse. In fact, there's only one little piece of high ground left on the entire site. And our building, if it were not raised, would definitely be inundated. So before we actually got this job, Sasaki did a masterful job on an overall campus master plan and a site plan, a site proposal for this particular building. And at the time, they were recommending that there was probably really what was going to turn into a 6-inch freeboard, and but it was to raise the building to 17'6". So what this slide is basically showing is, do you do either wet? Do you just sort of do wet flood proofing, or do you do dry flood proofing? The school was definitely adamant they wanted to do dry, and so when we chose to do that, they were also more conservative about how high they wanted the building, how much freeboard they wanted. So we elected to go up 6 feet instead of 5'6", and so now the building is first floor is at 18 feet. And one of the crucial things was making sure that the electrical systems, which
is that yellow segment there.
Yeah, so that's all at 18.
Even higher.
Yep. And so what you can see here is how we had to regrade it. And a lot of the challenge to go up 6 feet on the west side versus 5 feet on the east is that we also needed to make this fully accessible, and we didn't want any ramps. We wanted nothing more than a 1 in 20 slope. And our landscape architects, Traverse Landscape, did a terrific job with that. So let's just give you a little campus context. So the buildings on campus right now are all of these you see, and I realize we have to move really fast.
Yes.
All of them basically are 13 feet above sea level, and right now, the base flood elevation ranges from 10 to 15 feet, so almost all these buildings get inundated. And for the 2070, it's way worse, from 13 to 17 feet. The school definitely elected to design for the 17-foot level. And by the way, the FEMA flood level, the AE flood level, right, is at 17. So we built a building at 18 feet above there.
But they'll be struggling with what to do with the rest of the buildings over the next quite a few years to raise them up or retrofit them or whatever.
Luckily, the high velocity zone is further north away from the site, so we don't have to worry about that. Okay, so landscape strategies. I'll go really quickly. The main thing that we did was that we elected to do infiltration stormwater systems that are underground. And you can see them located here at the natural slope locations on the site. The high performance NEP is all about saving
you covered a lot of this
money on that. So I think one of the things that actually I do think is very cool is this here, because what this demonstrates is that when you're looking at the baseline approach to the executive order, when you have geothermal available, you can make a huge difference. And the baseline was anticipating a lower fan load than we actually have, but you can see that with all of the geothermal benefits, we were able to crunch this down by 43%, so that's pretty exciting. There's the geothermal loop. The building was projected to be 51 kBTUs per square foot per year, and we got it at 52, so that's pretty good. And Sasaki thought it was going to be rotated 45 degrees to align with north, and we actually managed to do it with the building not rotated, so that was pretty cool.
At the campus's preference.
Yeah. It made a lot of sense for a whole ton of reasons. Yeah. Anyway, this is just a quick chart that's showing you how we were able to get...
These charts are great to work with an owner.
Yes, BR+A did a wonderful job on these.
Yeah.
And you can see we went for the better approach here. And the important point is that we're trying to get resiliency for a building that will run on its own for at least 48 hours. Here's our beautiful wall section.
We could do a whole talk on.
That we're very proud of. The alignment of the rock wool with the window is very beautiful, and we're extremely happy about that. And we were able, in the non-lab spaces, to use natural ventilation. So all of the small blue section there is all naturally ventilated with operable windows. We made a very, very strong effort to keep our window wall ratio down as low as possible. And so we actually managed to get only 22%, but we still got a lot of nice light and views that are accessible to all
Really
these rooms.
daylit, view-oriented teaching spaces.
Yeah, and that saves a ton of money and energy. So when you compare the baseline to what we did, so the baseline, U factor was 0.3. We managed to get it to, we were able to go to the 0.23 because we got that variance, which was really exciting.
And if it wasn't a lab, it would have lower energy.
Yeah, it would definitely, yeah. And so the other thing was just reducing the embodied carbon. The areas we were able to make a difference was really in the concrete spec, the steel spec. The thing that's interesting about the steel is that we went from W shape to tubes. And by doing that, we actually were able to reduce the steel weight, but still have the right strength. And so we had less embodied carbon as a result. We paid an awful lot of attention to windows for reducing embodied carbon. So that reduced optimized window wall ratio was a big deal. And then some of it's sort of the last percentage of carbon savings that we got out of the windows. And then lastly, for the resilient benefit of human health, wellness played a really important part in the design of the building. And part of it was inspired by COVID, frankly. And so because we want a building that's also something that can survive the next pandemic, it has like these benefits like MERV 14 filtration. So, all right, there you go.
Thank you very much.
Thank you so much. That was wonderful. Jacob and Peter. And next we have Tyler Hinckley from Perkins & Will, Director of Regenerative Design.
All right. I'm going to use this so that I don't have to stand back here. Can you hear me?
There's a little button.
Just push on.
How's that?
Yeah.
Okay. More on the topic of resilient design. In this case, we actually designed a building to flood. So I'm going to tell you all about that. That's me. This is a condensed version of a longer presentation that I've given a few times. We're going to give a highlight on the overview. A lot of this already been covered tonight, so I'll go through that quickly. And we'll just talk about the case study here of our project at Columbia. So I'd like to start with a little bit of personal connection, and I think probably all of us have something like this. This is my parents' house on the South Shore of Long Island, flooded, 3 feet of water in their living room during Sandy. This is actually a rebuilt house after their previous house also flooded and therefore burned down, and they rebuilt it at a much higher elevation to the current flood levels required, and then it still flooded again 3 feet of water. After this, I shifted to teach about resilient design. For the context, again, this is New York, right? Sandy was pretty fresh in the minds of a lot of people, and this is Columbia University in New York. So folks have already talked about this. Mitigation is important. I have to keep doing that, but adaptation is critical going forward. That's the message here. We have to think about resilience as preparing to adapt and endure and thrive within the context of our environment. Couple things specifically about resilient design and the kinds of ways to design our buildings and our places to be resilient in terms of goal setting. So in this case, we were on the number 3, right? We wanted to be able to not just maintain kind of life safety, but be able to bounce back. But this was an athletic facility, and so it didn't need to have continuous operation. It's right on the water. If there's a huge storm event, nobody's playing tennis. But they want to be able to play tennis shortly after. So that's kind of the context of what we're dealing with. Reminder on dry floodproofing and wet floodproofing, that's already been covered by a few folks tonight. Dry floodproofing is keeping all the water out. A lot of work and effort and cost and materials in order to do that. And I think we probably all know it usually still doesn't work. Or it is a lot of maintenance to make sure it keeps working. What floodproofing is letting the water in. So, for the context of this project, this is a tennis center for Columbia University. Their athletic campus is on the very northern tip of Manhattan. So they have their primary campus, which is down here on Morningside. Then they have 2 other campuses, and then they have the Baker Athletic Complex, very northern tip of Manhattan. If you've ever driven into Manhattan on the Henry Hudson Parkway, you come over that bridge, you can see down to the football field. If you've ever taken Metro North in, you go by the site right there. This is what it looks like, you know, that bridge on the right, and what it actually used to look like, right? This is Inwood Park, and it's one of the only places left in New York that's quite close to what it was a long, long time ago. So that's some of the context that we had to work with. This was what it was when we got there. Existing 6-court tennis facility, air-supported structure, so a bubble. So if you went to go play tennis here, you would have no idea that you're in this amazing place, right on the waterfront. And so thinking about that opportunity and the challenge of this project, we wanted to take advantage of this site. It's a pretty amazing site. And there actually aren't a ton of sites in New York that are that close to the water. I grew up in New York, and it's surrounded by roads, and you don't have as much connection to water as you might think, as we do here in Boston. So this was a great opportunity to take advantage of that. And from the very beginning, you know, goal setting, that was critical. Engaging with the waterfront, but also, remember, people were very fresh in their minds about Sandy. And so we did a study first, where we evaluated from another bubble all the way up to a new building, full construction with rooftop tennis courts. And it really came down to 2 options. This was option 4, which is elevating the whole building and way above potential flood levels. And the other option was to build it on grade and have a dry flood-proof ground floor. And we did an analysis, and option 3, on grade, traditional, with concrete walls, dry floodproofing, won. It was just a lot less expensive. You can see like almost a $10 million delta between building it on the ground and building it way up in the air. So that's where we started the project after doing the study. Reminder, Sandy did not actually flood this site, but it was close. And another reminder about some of the other presentations, current FEMA Fern flood insurance rate map tells us that this isn't going to flood. And even the preliminary Fern for future, it's not going to flood. So this is all sort of looking backwards, right? So we actually weren't required to do any of the things we did by code or requirements from the city. But if you do look at the projection for sea level rise and you do look at those risks, then you can realize that the project is at risk. It's not at risk for the 1% storm, but it is at risk for the 0.2% storm. And the idea here kind of prompted our solution. And so, again, just kind of highlighting where that finally becomes a risk for the project when you have those bigger storms in the future. And so what we asked is, how can we work with nature instead of fighting it? And so this is just a picture of the project, and I'll tell you how we got there. But you know, as I kind of previewed, the answer was to work with the water. And I had to leave out the other aspects of this presentation on light and air because of time constraints, but that was a big part of it as well. Just a few diagrams here to show the idea for the project. You can see that bubble, the basic massing, the relationship of the athletic volume to the support volume, the idea of bringing the landscape in, and this actually, side note, this extends the pathway that surrounds Manhattan a little bit further. It used to stop here, right? You could go all the way up the Upper West Side, and we extended it a little bit further, so that's kind of nice to extend that publicly accessible pathway. Diagram some of the various sustainability features that I won't go into all the details, but we incorporated a lot of different strategies throughout the project. The program, as I mentioned, primarily a tennis facility, primarily serving their varsity programs, men's and women's programs, but it's also a community center. So you have 6 indoor courts on the ground floor and then 6 more on the roof with support spaces in that volume on the end. This is just a floor plan that shows those 6 courts, the associated support spaces on the end with spectator seating. And then on the upper level, there's a balcony that overlooks the courts. So mentioning again how we use those design flood elevations that others have talked about here to help us decide how to approach the project and what to design for. And so this is really it right here. At a certain point, we're kind of tiptoeing around this idea of, raising certain parts of the program, and we finally said, all right, I had this moment where I was pitching to our internal team the kinds of things that I teach about, and saying, what if we actually just let the whole first floor flood? And I was a little nervous about doing that because I thought it was kind of a wild idea. And it actually was the first time that we really crystallized the design, because it became the defining characteristic for the project and allowed us to kind of rally everything around that. And amazingly, when we presented to the clients, they didn't even bat an eye. They was like, well, that's brilliant, and our risk people love it. So great, go forward. And we never had to worry after that. I thought that they would hate the idea. So the basic approach is design an entire first floor to be able to flood. So it's hardcourt tennis courts, it's locker rooms that have CMU walls, it's polished concrete floors, right? And it's integrated flood vents. And so those flood vents surround the entire 3 sides of the building that isn't against the hill. And we integrated those flood vents to let the water in and out in the case of a huge storm. So after a big storm, the water can come back out, you've got to bring a cleanup crew in, but you're back in business in a matter of days. Maybe you have to replace the area rug at the lobby. This is a detail cut through that section, so you can see the flood vents at the exterior, the locker rooms with the CMU walls and the elevated lockers, the allowance of the water to flow through, even the interior glass partitions that separate the circulation zone from the tennis area. Those are spaced apart, wide enough that the water can go through, but not wide enough that the tennis ball can go through. Some of the details, so very standard flood vent products. I think that we saw that in the guidelines for Boston as a strategy, simple products integrated here thoughtfully into the coursing of the masonry at the base of the building. We figured out how to use a flangeless option and integrate that into the way that the corbelling of the masonry units were detailed, to really celebrate the fact that we're letting the water in. And so what that resulted in is a building that is connected to the waterfront. So we have, instead of a concrete, dry-proofed bathtub, we have a building that when you go there and you watch a tennis match, you know that you're in this special place. And you can see the water and you can hear the water or the birds or the breezes coming by, both when you're inside the building as when you're on the roof. And so I think that was really what led us to achieving those goals that we set out from the very beginning. And we kind of measure ourselves against those. And yes, it had to be an athletic facility. It had to have 6 indoor courts. It had to have 6 outdoor courts. But it also really had to connect with that place. And so letting the water in allowed us to not have to turn our backs on that place. And that informed all of the design decisions throughout. And I wish I could tell you more about the facade and the roof, but that's for another time.
The air and light pieces.
Okay, so we're gonna go right into our next, right?
Yeah, and I'm gonna
Okay.
use one of these mics because they sound way better.
Okay. All right, so Jacob and I have been teaching for a number of years.
It's like very small
Oh,
on the screen.
how did that happen?
I don't know.
I need to.
Yeah, do it again. See if it'll.
No, it won't do that.
I think you click. Yeah, there you go. Good. Much
Better?
better.
Okay.
Yeah, much better.
Okay, so I mentioned that after Sandy, I kind of pivoted towards teaching about resilient design and have been teaching this course for a number of years. This semester that we're going to talk about today, we aligned with the COTE Top 10 competition that the ACSA and AIA organize. And we're going to share just a little intro about that, and then you're going to hear plenty more from our students who won the competition. Why won't that go? Okay, I mentioned the kind of history of this course. We've used various different sites and topics. We've relied heavily on the Climate Ready Boston planning that we talked about earlier. Many of our studios are located in Boston. We teach at the BAC, and it's great to have a local site. And so we reference a lot of those standards, those guidelines, and South Boston, East Boston, Fort Point, all over. And so it's been a great progression. We've also had collaborations with the Amsterdam Academy of Architecture in Amsterdam, as well as talked about different locations around the globe. But today we're going to talk about South Boston. Do that. Okay, you're going to talk about competition.
Yeah, so the competition for this semester was based on the AIA COTE Top 10 for students, which is in its 10th year of running. And at this time, was a few years ago, the Top 10 for students competition, and since it's more of an open competition, so it doesn't have a defined program or a defined site. Instead, it has a really structured framework based on the top 10, on the framework for design excellence and its 10 points, which includes a whole bunch of the things that we care about in this presentation, like zero carbon, equitability, resilience, healthy and accessible projects. Why did it change on that screen? Oh, so the tagline, together we are designing a sustainable, healthy, and equitable world. The really difficult part of this competition, and I'm sure the students will talk about it, is trying to fit all of the work associated with the 10 different points of the framework for design excellence in 16 weeks in a student competition project. And trying to hit and think about and integrate into the design of an otherwise very complicated fire station, preview, all of these various different elements, and find sensitive and innovative ways to do that that make their project stand out.
So to do so, we picked a site in South Boston. I'd actually conceived of this studio with another colleague the prior semester, and it didn't get to run, so we kind of were able to pivot it to this studio. And it actually related a lot to the Climate Ready South Boston report. That other colleague of mine, Rob Adams, helped author that, and so kind of was thinking about how a firehouse that isn't actually threatened by sea level rise still fits into the resilience approach for that whole community. And we picked an existing firehouse and its adjacent site as the program and site for the project. And so I'm just going to say that we had 3 different student teams of 3 each. And the way that we framed it so that we could get a wide range of solutions is one team, team 3, actually was required to have an adaptive reuse approach. So they had to use the existing building and add on to it. And so that really defined their approach and their design solution. Sorry, that's actually team 2. That's team 2, sorry. Then team 3, they had to use a multi-story solution. So they had to have more than one story. And that meant that they were going to have more site area that wasn't built upon. And then the team you're going to hear from tonight, their challenge was one story, which we knew was going to be a big challenge because it meant that it would take up most of the site area. And we weren't quite sure what the solution would be from all of those. And that's the exciting part. And so with that, we're going to hand it over to our students. Thank you. Hit the page down.
Okay. Does this one work? Okay. I think I'm gonna control. So, or do you want to?
Oh, look at that.
Okay, let's see. Page down.
Can you see this?
That's us. Oh, okay. Well, we're going to introduce ourselves. So thank you guys very much for the introduction. So my name is Betty Chen. I am a graduate of Boston Architectural College, and I currently work as a design manager at Gensler.
I'm Alexis Winston. I'm also a graduate of the BAC, and I currently work at the MSBA.
I'm Rohith. I'm also a graduate from BSA. I currently work at Next Space Studio.
Okay. So we already had a very great introduction, but we'll just kind of reiterate that for the goals of this fire station, I think one of the questions that was asked in the beginning of the studio was, what should a fire station of the future be? And most of us know what a fire station does. It's an emergency response center. Firefighters respond not to just fires, but all kinds of emergencies. But we also wanted the space to be like a safe haven, a community center, and a healthy space for mental and physical well-being. So, you know, one of the things we started thinking about was already like green space, recreational space, in a ask where we actually are not building, or where we are building a one-floor program where there isn't going to be a lot of site. But anyway, that was a challenge we were faced with. And so we kind of responded to that question with another question, which is, what if the fire station was lifted up from the ground and transformed into an elevated experience?
So as Tyler and Jacob already mentioned, the site is in South Boston, and it is the development of a new fire station and emergency response center on the site of an existing 1930s fire station. And the footprint of the property for the purposes of our project will expand into the adjacent parking lot of a grocery store.
And we started studying the site, and as Tyler and Jacob mentioned, we went through a bunch of resources, one of them being the Climate Ready Boston report. We looked into the coastal resilience solutions for South Boston, and there were just various resources we used, and we realized this site, its surroundings have a lot of impervious surfaces. There's a significant heat island effect. I know we're all cool in here, but today was really a great day to talk about this particular project, because very early on we started to focus on the extreme heat aspect of this site, because again, the station itself is located at one of the higher points of South Boston, so it itself isn't in a flood area even when you project it way into 2070. It's not in that, it's not threatened, which makes it a really good spot for an emergency response center, so other people could come here in the event of an emergency. So we then really looked into mitigating heat, and this map shows like the red areas are very high temperature zones, and our station is a part of that red area. So yeah, like, well, and again, we have so much more that we had in this presentation, but to condense it down, we kind of went through the studies about like sea level rise, storm surge, and really just focused on like how do we mitigate heat, but really how do we ensure health and safety for the community, which is what firefighters also want.
The main design came with the idea of lifting up the ground plane.
So the page down. Yeah.
Yeah. we didn't want the fire station to be just a closed civic building. We wanted the site itself act as a public infrastructure. So the landscape elevates to a park and creates a civic surface on an operational fire station.
Yeah.
The massing then carves to allow daylighting, circulation, and programs pass through it. The result is the building not just placed on the site, but shaped as part of the terrain.
So the program consists of a firefighting apparatus, firefighter and living area, the department admin area, training pool, and a community center with multi-purpose spaces. The apparatus and pool will require the largest areas with the highest ceilings, so they're positioned at the two ends of the building. The site is composed of various permeable surfaces, water features, rich biodiversity, outdoor recreation spaces, and stormwater management infrastructure. An elevated rooftop park provides a different perspective by lifting people out of their usual vantage point and allowing them to briefly escape from the typical city environment. The structural system was inspired by
awesome.
with the sunken structure allowing space for the tree root systems on the roof.
And of course, while we were doing this project, we knew we were going to enter into the COTE Top 10 competition. So this whole time we were studying the framework and the AIA framework for design excellence. And we really wanted to look at it from a perspective of how we can integrate all of the 10 criteria and not just look at them individually. And because that really is the way to do it. But at the same time, we knew that there were going to be certain aspects that we focus on. So even though this site isn't in the flood zone, water is still a very important component. City of Boston Fire Department actually has a high water vehicle and high water training program, so they respond to flood emergencies. And so in the apparatus here, this is where some of the high water vehicles can be housed, and then the pool can act as a high water training facility for the firefighters from all over Boston who can come here for the training. And so yeah, we decided we wanted to integrate things like excuse me, rainwater harvesting, stormwater, there's a stormwater, where's the mouse? There's a stormwater retention system as well, and which will control the runoff, but also recharge the ground. As earlier Lexi mentioned, we have a lot of vegetation cover on top so that we can absorb the water, and there's, I can probably go on, but we have a condensate capture system and then we use geothermal as one of our energy sources. We just decided to go all out with water, and of course it's a student project, so our budget's unlimited, and that was very helpful too. So we're like, why not? But again, throughout this, we reviewed a lot of data from Boston Water and Sewer, and we looked at benchmarking, and we wanted to make sure we present this as a realistic solution where it can be sustained on its own with regards to water.
So the existing site consists of mostly impervious surfaces, and a rooftop park and increased green space will bring carbon sequestering opportunities, improve air quality, and decrease land surface temperature in the area. And it also promotes increased biodiversity and incorporates indigenous, non-invasive vegetation tolerant of varying conditions so that there'll be less need for watering and maintenance as well.
And going back to what Tyler was mentioning earlier, we were told that the one-story program is what we will design for, but actually throughout our research we realized that one story is actually the best choice. There's a lot of research about firefighters and their work, and one story is the safest and most efficient. Most of us probably imagine the fire pole of firefighters coming down, but that's actually not very safe. And these purple and red arrows you see here on the floor plan, it indicates the response time and path from from the farthest points away. And so we wanted to make sure that at any point in this area, whether the firefighters are working or like in the offices or in their bedrooms, they can get to the apparatus in like 60 seconds or less. So that is their requirement. There's an emergency, they're supposed to get ready in 60 seconds. So if they're and the alarm sounds, they got to get there in less than a minute. And as someone who takes an hour to get out of bed sometimes, it was very interesting to design for something that's like very, very fast. And so like we wanted to ensure that the apparatus had good sight lines. It is on the corner of the lot. And then there are some fire stations and some of our colleagues designed like pull through where it goes in one side and out the other. But again, we have a constraint in terms of sight. So we ended up just having the garage doors from one side, which meant we had to do a bunch of studies for truck turning to make sure they can actually get in there. So.
The elevated park features rich biodiversity of indigenous and non-invasive plantings that include wild grass, trees, flowering plants, and shrubs. Open areas throughout the park provide opportunities for outdoor events, exercise, pop-up markets, and outdoor performances. And this view also shows the apparatus bay from if you're entering from K Street.
The apparatus bay is designed to be functional, durable, and an expressive space. The timber structure gives warmth to the highly technical program while maintaining clear spans and efficient movement for the emergency vehicles. In contrast, the firefighter's bedroom focuses more on recovery and well-being, daylighting, natural materials, and a quieter scale brings a restorative environment for people working under stressful conditions.
The exterior of the building is clad in shosugi bond siding, which is wood treated with intense heat that burns off the cellulose in the wood, creating a protective soot layer, making it resistant to water, fire, UV, fungi, and pests. It's low maintenance, durable, cost effective, and symbolically representative of the fire station.
Glulam and CLT allowed us to reduce embodied carbon while expressing the space honestly. They make, yeah.
Oh, sorry. And then in addition to that, the insulation material we used it was a wood fiber product, which is also renewable and locally available. And then for the roof decking, we opted to use a composite. The glulam provides the structure underneath, but then the roof deck is, we decided to go with a low carbon concrete, so concrete with high SCM content. And so, while this project has a lot of high aspirations, we did want to just realistically look at, really in order to have all that soil on there, the concrete was most likely the actual more practical solution to go with. We're showing, we wanted to ensure the space has high performance insulation and triple glazing. Again, there's a lot of criteria in the framework that we had to hit. But I think altogether, we wanted to make sure that we can explain this in a way that is practical and not just, we're gonna throw everything at it.
This diagram shows how daylight supports well-being. Most of the occupied spaces will receive a strong daylight, while the darker spaces are mostly service spaces.
Yeah, and one other note on well-being I forgot to mention earlier, in the floor plan, a lot of the way that we designed the spaces and the sequence of where all the rooms are, we're also based on ensuring that there's a decontamination flow when the firefighters get back from responding to an emergency. And again, in our research, we found out that firefighters are exposed to a lot of toxins and carcinogenic materials. That's really not good for them, and a lot of existing firehouses are not designed to ensure their health and safety in that aspect. So again, that was a really high point to focus on to make sure the firefighters are as healthy as they can be. And so, yeah, we wanted to target net zero operational carbon. We used a baseline of 55.6 kBTU, but we were going for a 55% reduction. That was our target EUI, and so, you know, through the high performance envelopes, we're using like solar heat capture, daylighting, natural shading, and we're introducing, or we want to include this efficient hydronic system. Our energy sources are mostly coming from the geothermal and on-site solar, and yeah, throughout this project, like we learned a lot of new tools. For instance, like we used the Zero tool. We looked into you know, solar panels and how they work and how efficient they are and how much energy we can actually capture, which was actually not a lot. So we had to rely a lot more on the geothermal system. Yeah, again, like like it was a real goal of us for us to just have not only a concept, but like a proof that like this could actually work, as long as you have a lot of money.
The modern fire station combined with the community center could provide safety, security, and protection, which allows the firefighters to serve the community better. And a new community center aims to promote equitable access to community services and cultural engagements. And the elevated park, accessible by stairs, ramps, and an elevator, supports improved air quality and grants the community with new space for wellness and socializing.
Community center and water treatment area are visible learning spaces. We want sustainability to be a part of public experience.
Yeah. Oh, and I think we actually did speak to some firefighters throughout this process, and I did learn that a lot of firehouses already do host tours for like kids and students and things like that. So this really helps to kind of expand that. They're already doing it. Might as well have like all these like showcases of how our water filtration system and how these things actually work, so that they can not only learn about the firefighting, but also get inspired for like sustainability and resilient design. And just kind of going back to the beginning, like our objective was really to serve the community, for this to be a community destination, as well as showcase the critical work of the firefighters. Again, like parks, like we really wanted to make sure that we have a lot of green spaces in here, you know, looking in studying urban parks and walking around, we really noticed that like existing parks, like they do create, they are these nice environments for you to escape from like the hot and busy urban areas, but they're not always integrated with the neighborhood or with the buildings. So why don't we do that? Was essentially our overall concept. And so like, even though this was a project about like sustainability and making sure we follow this framework for resilience, we wanted to make sure our goal, that wasn't actually our like ultimate goal. It was really about serving the community, and it's about ensuring health and safety, not just for people that work there, but also for everyone that comes here. And really ultimately that is the goal of the framework, is to make sure we all, you know, live in a comfortable environment. And yeah, so in the end we decided to create this thing that is where people can come enjoy like tranquil and cool green spaces, recreational spaces, and have it really be like a holistically integrated park within the building and the neighborhood. Thank you.
To stay up here.
Oh, us or everybody?
Yeah, I'm going to invite all the speakers to come on up. And oh, these guys provided an appendix. Look at that.
Oh, sorry. Yeah. We had so much we couldn't include.
There's a lot of extra.
Amy, can I add something? I don't know if I mentioned, did I mention that they won? So there was I'm sure most of you are familiar with it, international design competition, thousands of participants, hundreds of teams, over 1,000 participants, and over 600 entrants. So there are 10 winners, they were one of them. So proud. So
thank you.
Kudos to you.
Thank you.
I'm just checking the online chat to see if there are any questions online. I saw somebody didn't have sound at 7:12. Sorry about that. And for filing credits, there's a little QR code for everyone in person. And did everyone online get those? Yeah, you can come off mute if you want to ask a question, or anyone in the audience.
I have a couple of questions. First, I want to apologize to Derek for interrupting the presentation.
You're good, you're good.
Questions to the end. I have two questions for Amber. In developing sort of your threshold for triggering for the 6 building types that you had, was there any associated cost modeling that informed those decisions? And then my second question is, for the people that have permitted and implemented the requirements, is there a reduction in their insurance rates? Like, does the insurance industry recognize the benefit of making these improvements and reducing the risk to future property damage?
Two very great questions. Right now, an effort that...
We just can't hear you very well.
Okay. An effort that the city is currently going through, specifically a team at ISD, is looking to get the city into the National Flood Insurance Program, and that program provides discounted rates for residents on their flood insurance. So complying with resilience and having the documentation that you've gone through that resilience review is something that they can use, those residents can use once the city is part of the National Flood Insurance Program. Insurance, that's about as much as I know about it. I'm still learning, but that's one piece that, yes, it's helping the city in general, and it's also helping residents in general in that process for flood insurance. And your first question about the size thresholds and building typologies, those studies were done before I started with the city, but from my understanding, there were many studies done of what threshold makes sense, and it seemed that the best strategy was to integrate in the current processes that the city already had, which is the Article 80 process. So Article 80 small and large projects are required to have resilience review, and it's part of the Article 80 process. And Climate Ready, not Climate Ready, the Climate Action Plan that was just released last month talks about envisioning of how 25A could evolve in the future to expand to protect a wider variety of properties. So those are future things that the city is currently studying. Thanks.
I have another question. Sorry, for the gentleman from the Arab team, I'm having a hard time getting my head around the inverse relationship about, not Arab, excuse me, Ellenzweig, apologies. The inverse relationship of wind speed to triple glazing, right? Did I hear it correctly that the higher the winds, we need to drop from triple to double?
That's right, because there isn't a triple glazed system yet that has a laminated interior glazed design. So right now, triple glazing is typically 1 3/4 inches thick. And if you try to add the laminated, it gets beyond the size of a typical mullion seat.
Okay, thank you.
Yeah.
I have a question. So for the student group specifically, but then kind of like broader to also all of you guys, I'm Sarah. I was a student of Tyler and Jacobs this semester, so I understand the privilege and the struggle of that. So I appreciate your efforts. Thank you for sharing. And so I kind of wanted to ask you, brought up like some of the research that you had done throughout the process, and obviously we're not all experts in resiliency and sustainability coming into school. So how much of this was research that was like you searching out studies or anything that you've done, or what was like kind of new discoveries? And so like kind of the question overall is, how were you designing with information you didn't know or were learning along the way?
That's a great question.
Yeah, I would say like a lot of it was, a lot of this information we were coming across for the first time ourselves, and we did do a lot of research. We also had some very helpful instructors who were very knowledgeable and can help us, like point us in the right direction. I can't speak for everyone, but I also personally am pretty lucky where I work at Gensler. I work very close with a couple of colleagues who are literally our sustainability experts, technical directors, so I literally asked some of them these questions, or like, how can I like find out more information? So yeah, I think a lot of it is about reaching out to these resources, but also there was some stuff that like we kind of just had to like guess and you know, just be aware that we're not going to get super in depth into some of these systems, but the ones that we could find out info about, it was nice to learn about them.
Thank you. Thanks. There might be a question online. I just see that there's a, let's just go to that one. Oh, it's just, oh, sorry, that's I asking if the sound working.
That sounds working. Hopefully it's working for them. Hey there, I have a question for Derek from AIA. How long, a couple of questions. How long did that project take? And were there any provisions to change any of the existing electrical infrastructure? I'm a lighting designer, I'm working on a parking project, and I'm just curious how it might map out for other cities too.
Yeah, no, great question. So the Wharf District project we did first. That one, I think we spent 3 years on. The North End project came immediately after, and we built on the lessons we learned from Wharf District to do that one faster. We did that one in about a year. In terms of the electrical infrastructure, we didn't really look to modify electrical infrastructure. We were focused really on the neighborhood line of protection, which was, we really tried to keep that outside the building footprints, while advising the property owners to incorporate additional level of protection at their buildings by adapting their buildings to the city's standards. That's where they would have come into some electrical upgrades potentially, but we weren't really looking at the buildings themselves. So for the neighborhood plan, not really getting into the electrical. But great question. Oh, and I meant to give a plug. We have a neighborhood resilience planning handbook on the Wharf District Council's website, which goes through all the lessons learned and the tools that were created and used through that process. So if you're interested in more on the website, it's all up there.
Other questions? I'll make a plug. So this is second in one of our events this year for BSA COTE. We're going to have a Chatham Rules discussion on 2030 reporting, and I will get some engineers in there too, energy modeling folks, to talk about challenges if firms aren't reporting or what those things might be, as we have a member of the 2030 working group on our committee. And then we're also going to do a book talk. Jessica, and we're getting Carl Elefante's Going for Zero, his book, and talking about sustainability and preservation, how they go hand in glove often, and sometimes they fight. That's on our agenda. Any other?
I actually have a question.
Yeah.
For Derek. I'm just curious, is the onus of financing on the owners of those private properties, or is the city kicking in some help for them?
I hadn't gotten that question before. I'll come up so folks can hear. But a great question. So the question was, is the onus for paying for the flood protection plans for those neighborhoods on the property owners, or is it a public-private partnership, or what may it be? So excellent question. Generally, we were looking at, I think for the Wharf District, $880 million to just do the Wharf District, and the North End's probably another $600 or $700 million. Property owners aren't paying that. They don't have that. And you got to keep in mind, they need to adapt their buildings behind this line of protection in addition to this line of protection. So they have their own costs. So to build that consensus, a big part of it was the property owners are not initially saying, we're going to foot the bill for the citywide protection. And that was a requirement of many of those property owners. But what we're doing now is working with the Army Corps as a first biggest potential bucket of money. And as I mentioned, we've incorporated in the plan. So the Army Corps would pay for up to 65% of the flood protection costs. And then the state, city, other means need to figure out where the rest of that comes from. Green Ribbon Commission right now is doing a really interesting study that I'm really excited to see where it comes out of it, to look at how the city and state can fund the remaining bucket, that at least 35%, really it's going to be a bit more than that. And I do think part of that is probably going to be looking at, not just, grants and philanthropy, but some ways that we can look at, fees through Boston Water and Sewer or other, business improvement district funds, financing and different ways to approach it. So it's going to come, there will, I think, be some amount of money that comes from the tax base generally through either fees or taxes, but a lot of it's going to be hopefully federal, and then some state. I see the smirk there, but yeah.
Well, the feds right now, they don't like our city much, but well, when would it begin? When is the earliest that construction, the groundbreaking?
So I know things are crazy with the feds right now. Flood protection has always been bipartisan, and our bit of work gets lumped into the entire FEMA budget generally. So it's not like the federal agencies being like, Boston, no. Regardless, still an uphill, bit of uphill to get there. But 2027, the Army Corps is going to submit their recommendation to Congress for federal funding to complete the design and construction. So that's the first bite of the apple. It's the first time we can say we want in. Construction wouldn't start until the 2030s. They're looking to wrap up all of their construction on at least the priority areas of Boston Harbor flood protection by 2040. So we're probably not looking at any real protection from the Army Corps until the mid-2030s would be my best guess. And if we don't get approved on the first pass, we'll apply again a couple of years later, but then the timeline keeps slipping.
Yeah, water keeps rising.
Yes. Yeah.
Thank you.
I have a question that's not directly related to any of the presentations, but I figured I'd ask because it seems like this is the right group of experts. So wondering about large-scale green infrastructure resiliency, like on a city or neighborhood level. A lot of Boston's infrastructure and basically topography is man-made. And some of it is conducive to resiliency, and some of it is unfortunately not. So things such as channelization that's happened in the decades past of rivers, like straightening them, and then not having that buffer to protect against stormwater and flooding. I'm wondering if you've seen any large-scale projects or even early pilot studies elsewhere, because right now what I'm seeing is mostly Europe that might have stuff like rewilding rivers, daylighting rivers, building in that large-scale green infrastructure. But I'm wondering if you've come across any projects maybe more domestic or stuff like that.
I have a small, quick answer. Maybe somebody else has a bigger one, but I would plug that our city does have a green infrastructure team, and they've been working across the city to identify potential areas where stormwater is currently collecting and adding green infrastructure. So there are quite a few of those that have been built already, and it's pretty amazing to see the quality of the plants there, especially the street trees, how much they've grown in just a few years. And there's public signage on all of those describing how much water they capture and how they filter it. So I would plug looking into the city's green infrastructure website.
And there, search for it.
Yes, City of Boston green infrastructure, and they have maps of all of those that have been built, so you can go visit them yourselves, and they're pretty incredible to start seeing more of those. And in development review and project review, we also ask that new projects coming in to use green infrastructure means and methods. Now that our green infrastructure team has published handbooks with some of those construction details and methods to do that here in the city. So they're a resource, and we're also on the planning side of things asking that team start using those in their designs.
Thank you. I would invite you to go to City Hall Plaza, which Sasaki has redone with 250 new trees on top of, within 6 inches of the Green Line tunnels, all sorts of crazy civil engineering below grade there. But what is really cool is there is a visible water, so rainwater falls, it collects, it's kind of filtered through the landscape, it's visible, and 80% of it is collected and then reused. And there's like a little plaque in the ground, you know, in the paving pattern that tells you that information. So it's educational as well as
I never noticed that.
Doing that. So it's where the new playground is, and the new north entrance. So go explore that.
And I'll give a plug to one that's not an ARA project. Cambridge Crossing is a fantastic spot, one of my favorite places in the city in terms of its confluence of multimodal transportation and green infrastructure. Some really cool wetland features that allow great access in that space as well.
It's not bad to be leading the way here. Right?
Yeah, Rohith and I are planting trees tomorrow. We're trying. Well, the recording stops in a minute. Should we, general consensus, wrap things up? Yeah? Well, this has been great. Thank you to all of you. Thank you everyone online. Thanks for joining us. Thank you so much. I'm gonna ask that
Good job.
Thank you.
We'll do a group photo before you go.
Lexi,
Before you go, we'll get a group photo. Thank you very much. Maybe we should go in front of the podium? Fine.
That's all. And we talking about.
You guys can be in a photo?